My students also feel welcome. Today, I just want us to go through this particular point on what we refer to anomalous expansion of water. Sometimes we refer to it as abnormal expansion of water. We are using the word anomalous or abnormal because naturally we know whenever something is heated, it's supposed to expand. But what happens is that water shows what we call unusual expansion, and that's why we refer to that particular expansion as anomalous expansion. So anomalous expansion is the unusual expansion of water, and this unusual behavior of water usually occurs between the temperature of 0 degrees Celsius to about 4 degrees Celsius. In this temperature, water usually contracts instead of expanding, and vice versa. And that's why we refer to that particular behavior as abnormal or anomalous expansion of water. So whenever you heat water from 0 degrees to about 4 degrees Celsius, water usually contracts instead of expanding, and vice versa. Now, if we were to take this information and then we represent it in a graph, that may be, say, a graph of volume against temperature, we are going to realize that the volume of water between 0 to 4 degrees reduces, but after 4 degrees it starts again to rise. Now, this particular behavior where water is heated and on the process of heating, instead of expanding, it actually contracts, that behavior is what we refer to this case as anomalous expansion. And if we are to draw this graph of volume against temperature, then you are going to have a dropping volume until 4 degrees, and then it starts to rise. But remember, from the formula of density, remember density is equals to mass over volume, and if volume reduces, then it tells you that density increases. So if you were to draw the graph of density against temperature, then from 0 degrees to 4 degrees Celsius, then you're going to realize that as the volume reduces, the density increases because the two are inversely proportional. And therefore, these are the two simple graphs that we can represent this behavior. A volume against temperature, the graph usually is a drop, but the vice versa is also happening for the graph of density against the temperature. So as the volume reduces, the density increases. So if you are required to draw this particular graph, this is the type and the nature of graph, if it is density against temperature or if it is volume against temperature. Thank you, and remember to follow me for more interesting lesson and video. Thank you.